The graphs below represent 100 years of data on 3 cities' temperatures, all in September. So all 3 graphs use 3,000 data values, and all 3 cities averaged 70 degrees Fahrenheit. So you can see they all 3 have, are they normal distribution curves? Yes, they are, because they all have that normal distribution curve going on there. And because of that, they told us the mean is 70. So if I draw a vertical line in each graph, that's at 70 for each one. Look at my line. It's right at the edge of 69, so I'm kind of consistent even in that. So compare the graphs. How are they the same or different? Well, we just said they have the same mean, but they're different because they have different spreads. Look how spread out the data is. With Indianapolis, it's really spread out. This is shorter spread. San Diego is more clustered around the middle, and Austin is kind of somewhere in between Indianapolis and San Diego, right? It's not really spread out a lot, but it's not clustered either. So it's somewhere in the middle. But they all have different spreads. So they have the same means, they have different spreads. And this gets us into standard deviation, right? This is the idea of standard deviation. So when we talk about standard deviation, here's the definition. It's a calculated value that indicates how much the data set deviates from the mean or average. Basically, we're saying if the mean is here and my value is here, how far away is it? What's the number of standard deviations away? It's a way to give a physical description, or I guess it's a numerical description, about how far away your data is from the mean, and it's a way to standardize it so that when I say 3 standard deviations, it's not, that's different than if I just said it's 5 away. Well, is that a lot? Is 5 a lot? Well, not if the mean is 10,000. Maybe 5 is close. So standard deviations kind of give it a more calculated feel, okay? So if you think about this, a curve with a larger standard deviation will have more spread out data. Because if the mean is in the middle and it's a really big standard deviation, that means my data might be, so I might have it something like this. Whereas if I have a small standard deviation, well, that means everything is really clustered around the mean. So it's going to be maybe high and tight. All right, so let's go back to the cities, and we're going to rank them in terms of temperature variability. So who has the most variation, who has the least, and what does that mean for their standard deviation? So when you're looking at these, okay, so San Diego is the high and tight. This is going to have the smallest standard deviation. And I say it's going to be the smallest because all of the data is closest together. The closer the data is to itself, or to the mean, the smaller the standard deviation. And Indianapolis is really spread out. So this is going to have the largest standard deviation. And then Austin is kind of in the middle, so it's going to have the middle standard deviation. So who has the most variation? Indianapolis. Who has the least? San Diego. So if we talk about standard deviations in terms of size, smallest to greatest, it would be San Diego, Austin, Indy. Just based off of their graphics. So let's use the birth weight example from above. Oh, here we go. Sorry, I lost it on the paper. What are the given values for the mean and standard deviation? Well, they're right here. So the mean is 3.39 and the standard deviation is 0.55. This symbol that I keep using for standard deviation is called sigma. Sigma is a Greek letter and it stands for standard deviation. It's really what it does. So a lot of times in graphics you're going to be given the mean and the standard deviation, but it's important to always recognize that you have them when you're ready to work. Ooh, next page. So below is 2 normal distribution curves with the same mean. So if you would draw a line down the middle, that's not really the middle, but it's close enough. So which curve appears to have a lower standard deviation? So remember, if it's a low or a small standard deviation, the data is going to be clustered around the mean. So which one of these is clustered most around the mean? Well, maybe that red helped you see it, but it's this one, which is spring. In which semester did they receive more Fs? Well, an F is below 60, so below 60 would be the dotted line, which is fall. And then when were more Cs earned? Okay, a C is from 70 to 80. Now, this is shared space, right? Both graphs have this space. So you're really comparing spring up here and fall right here. Well, obviously spring has more. So spring has more C's than fall. And that's that.